Sofia, and in this tutorial I'm going to talk to you about equalizers, parametric equalizers, and dynamic processing. I'm going to show you the different parameters of the tools and how I apply them on different sounds. These tutorials are made thanks to ABF in Sweden, our sponsor, and in cooperation with the music production program Vem Kan, Producent, or Who Can Become a Producer, which is a music production program held in Stockholm, Gothenburg, and Malmö for women, non-binaries, and transgendered people. Let's just start. Okay, so here's the Logic project. Just to have something to work with, I have this old song of mine. First I'm going to show you the equalizer. You can find it either by clicking here where it says EQ, or going to audio effects and choosing channel EQ here. So here it is, the parametric EQ. And the few basic parameters of this is the choosing of frequency here, where it says 20 Hertz up to 20,000 Hertz. Then you have the gain under, where it says 0.0 dB here. So either you can attenuate or amplify the chosen frequency. And then under that you have the range, or the Q value. So this is how narrow or how wide the range is. So either you can be very precise, or you can be not very precise at all, like this. And then you have the different filters up here, and these have different names. So the first is here, the shelf filter. It looks like a shelf. And since this is in the lower parts, it's called a low shelf. And this one is called a high shelf, since it is in the higher parts. And these ones are called a notch filter or a bell filter. Looks like a hill. And then you have the low cut filter and the high cut filter. Low cut is also called high pass, since it cuts the lower parts and lets the higher parts come through. The high cut filter is also called low pass filter, since it cuts the higher frequencies and lets the lower pass through. You can choose the steepness of the low pass and high pass filter here, where it says 18 dB per octave. And this is how steep it can be, and this is not very steep. So those are the basic parameters. Let's listen to how it sounds on this bass. First of all, I'm gonna just listen to it without the EQ. Okay, so with the EQ, first of all, I'm gonna cut out the sub bass, because this is acoustic sounding production, and I don't want the sub bass. Then I'm gonna use these notch filters to listen to sounds I like and dislike, to amplify them or attenuate them. as a start. Let's try it on another instrument. Let's try with vocals. I'm gonna do this in the same way. Just start by listening.
Your heartbeat, it beats so close to me.
Okay, so the sub bass has nothing to do with this song, so I'm just gonna cut it out with the low cut filter. And I'm gonna use it quite aggressively because I sing quite high, so there's not much information down here. And then I'm gonna listen
Your heartbeat,
to the low mid.
It beats so close to me. Your heartbeat,
Around here,
it beats so close to me. Your heartbeat,
so I'm gonna that a bit.
It beats so close to me. Your heartbeat,
I'm just gonna lift the treble.
It beats so close to me. Your heartbeat,
just to have some air in the sound.
It beats so.
And then just to bring the vocals forward, I'm gonna
your heartbeat, it beats so close to me. Your heartbeat.
It makes the vocals a bit clearer. So this is just the basic EQ on song, fastly done, and when you attenuate with this kind of filter, I often choose a narrow Q value just because I want to be precise when I attenuate, but when I amplify it can be wider and softer like this.
Your heartbeat,
so let's compare.
It beats so close to me. Your heartbeat, it beats so close to me.
So it's a bit more clear, a bit more clean. Yeah, that's it for the equalizers. I'm gonna move on to the dynamic tools. Okay, let's start with the compressor. The compressor you find under dynamics, and here compressor. So it looks like this. And the basic parameters are threshold, ratio, attack and release time, knee, and makeup gain. The makeup gain is set as a default, so let's just turn that off and do that by hand. And the release and attack time is also on auto here, so let's turn that off. To explain further, the threshold decides when compression is made, at which level. So the lower you have here, the more of the signal is affected. And the ratio here decides how much compression is made above the threshold. So if you have 1:1 here, it means that the signal above the threshold is not affected at all. It keeps its original level. And if you have 2:1 here, it means that above the threshold, the signal is reduced to half of its original level. And 3:1 means that it's reduced to a third of its original level above the threshold, and to a fifth, to an eighth, and so on. Then the attack and release time. This means how fast the compressor reacts to the signal when above the threshold. So if it says 15 milliseconds here, it takes the compressor 15 milliseconds to react to the signal and start compression after reaching the threshold here. And the release time means how long the compression is held after going under the threshold. Then you have the knee here, and the knee is just a way to make a smoother transition between under and over the threshold. So instead of being either or, compressed or not compressed, this sets a scale between the two. So the compression actually starts under the threshold, just a bit under, and then reaches the complete quantity of compression after going above the threshold. And then you have the makeup gain, and the makeup gain is just a way to bring back the lost gain that you lose when you attenuate the peaks, as you do when you compress. So let's just try it here on vocals. To start with, I'm gonna have a ratio of 1:1, so nothing really happens, and then a medium long release time and a quite fast attack time, just to hear it.
Your heartbeat, it beats so close to me.
So you can hear and see that nothing really happens. So I'm gonna bring it up to 3:1, so only a third of the peaks are left.
Your heartbeat, it beats so close to me. Your heartbeat.
Okay, so I'm gonna bring down the release time just to keep the compression going after going under the threshold.
Your heartbeat, it beats so close to me.
And it reacts quite slow to the transients, so I'm gonna bring down the attack and make it work faster.
Your heartbeat, it beats so close to me.
Yeah, that's how I would do it. Just keep the knee quite soft, maybe even softer.
Your heartbeat, it beats so close to me.
Now let's just listen to the input level and even it out to the output level with this makeup gain.
Your heartbeat, it beats so close to me.
So as you can hear, the input level is quite a bit louder. So let's just bring it up.
Your heartbeat, it beats so close to me. Your heartbeat, it beats so close to me.
Yeah, so now it's almost the same, so that's good enough. Let's keep it at that level. That's it for the vocals. Okay, so let's try it on the bass here instead. Gonna put a compressor on the track, and here it is. Let's just listen to how it sounds. So I'm gonna turn off the makeup gain auto thingy and the auto attack and release time. I want more of the signal above the threshold to be affected, so I'm gonna bring up the ratio and maybe a lower threshold to keep some of the dynamics still there. A slower release time used to even it out a bit. And then the attack time I'm going to bring up also because I want to hear the transient come through. And let's compare them. think. Okay, so that was it for the compressors. Let's try the expanders. I have a drum group here with a drum bass and a craboto, and I've sent them to a bus here on which I'm gonna place an expander, and here you can see the same parameters as in a compressor. So the threshold ratio, the gain here, which is the same as the makeup gain, but it doesn't make up for lost gain, it actually attenuates the gain. So, and then a knee attack and release time. And you have an auto gain here set on as a default. I'm going to turn it off and do it by hand. So to explain what an expander is, it is a compressor, but in reverse. The compressor produces the dynamics, and an expander expands the dynamics of the sound. So instead of attenuating the peaks above the threshold, it actually amplifies the peaks above the threshold. So the threshold you set to affect peaks or more of the signal, you decide, and then the ratio decides how much you amplify it. So if the ratio is 1:1, nothing is amplified, it keeps its original level. And as you go down, the more you amplify. The gain here is to even out the input and output level. And then you have the knee here, which is exactly the same as in a compressor. It just works to make a smoother transition between under and over the threshold. So instead of being either or, it is a scale. And then you have the attack and release time. And the attack and release time is the same as in a compressor. It means how fast the expander is going to react to the signal above the threshold. So if it's on 7 milliseconds, it means that it takes the expander 7 milliseconds to amplify the sound above the threshold. And the release time is the same. Also, it means that when going under the threshold, it takes the expander 98 milliseconds to produce the level again. Let's just hear how it sounds on these drums. Okay, so as you can see, the output level is now almost the same as the input level because I reduced the gain here. I could actually bring it up a bit. And you can see the level of expansion that is made here. We can listen to the difference. So you can hear the peaks a bit more clearly. If you want to hear them even more clearly, bring up the ratio or bring it. So that's how you use an expander. The reverse of a compressor, just to bring the dynamics up. If you have a very undynamic sound that you want to make more dynamic, then use this. Okay, so let's look at the limiter. The limiter in Logic looks like this, and it works in the same way as a compressor, but it has a ceiling, this output level here. If you set it at minus 1 dB, it means that the signal can't go over minus 1 dB. Then you have the gain here, and that increases the input signal. And the release time is the same as a compressor. It is the time it takes for the limiter to stop processing after the signal goes under the threshold. And then the look ahead is just that the limiter analyzes the material ahead of time. So 5 milliseconds ahead of time, the limiter analyzes the material to start limiting beforehand. Let's just listen to what it sounds like. I'm gonna exaggerate for it to have some effect on the sounds. So now you can see that the input level is actually at plus 2 dB approximately, and then the output level is at minus 4 dB, and that is because the reduction is made here to limit the sounds to going over this ceiling that we set. So the limiter is used on buses and when mastering to just glue together the dynamics of sounds and making sure that they don't surpass the 0 and distort or something. That was the limiter. Okay, so let's look at the gate, the last of our dynamic processing tools. You find it under dynamics and then stereo here. So the gate works as an expander, but it can be more aggressive. So below the threshold, the sounds are reduced here or completely silenced. So if it is, the reduction here is at minus 100 dB, nothing below the threshold is heard. But if you have it at 0 here, everything below the threshold is heard. Here you set the threshold value, and then you have this hysteresis. And this hysteresis works together with the threshold. So instead of the threshold choosing when the gate opens and closes at a certain level, the threshold decides only where the gate closes. So the threshold can be at one value and the hysteresis at another value, and the hysteresis decides where the gate opens. So this is where the gate opens, this is where it closes. Then you have the attack and release time, and it works in the same way as an expander. When dropping below the threshold, the release time decides how long it takes for it to stop being processed. And then you have the attack time that chooses how fast the gate reacts to the incoming signal. So if you have a very slow attack time, it will take a while for the gate to react to the signal. The hold here is a way to keep the gate open for a longer time. Then you have the look ahead that just chooses how long ahead of time the gate analyzes the material. Let's just listen to what it sounds like on these drums. So In this case, maybe we could use this to create a more apparent rhythmic pattern. I'm going to set the attack time at 0, so the gate reacts almost directly to the incoming signal, and the release time could be maybe longer. Let's just set the loop here. So let's listen to it without the gate. With the gate. Without the gate. So let's listen to what it sounds like as a whole. As you can hear, it does something to the groove, and it could be nice if you want to do that. And that was it for the dynamic processing tools and for this tutorial in a whole. So I hope you enjoyed this tutorial and that you learned something new. We are going to keep releasing these every Tuesday throughout this autumn, and hope to see you again. Bye.